This ESS revision video for topic 5.1, Introduction to Soil Systems, and today we will be looking at what soil is and about the composition of soil. So you need to understand that soil is a complex ecosystem. Soil is made of minerals which are found in rocks and then obviously in the soil as well, organic material called humus, gases and water. And soil is absolutely essential to life on Earth. The amounts of all these different things will give the soil its properties. But soil is important because all the food we eat and all the food that any organism eats is from soil. The plants need soil to grow, and therefore food and habitats are essential from soil. Soil itself is a habitat. There is organisms that live directly in the soil. It is a water storage facility, so it holds huge amounts of water. But also it filters water as water percolates through it, and it also has an impact on the atmosphere temperature because it has impacts of heat transfer through it. Now you need to understand then what it is composed of. Well, first of all, soil actually has its own layer called the pedosphere, which is a thin bridge between the biosphere and the lithosphere, and soil is composed of the following areas. A system of soil is composed in the following areas. So just like all systems, soil can be used for storage of these different chemicals here. Soil can transfer things, so there might be water moving through transpiration of soil, particles moving in soil. Soil has inputs because things like leaves land on the ground, decay into the soil, dead animals, energy from the sun enters through the soil, and it has outputs because soil erosion will allow materials to leave, it will release heat back into the atmosphere, and there's transformations happening in soil, the main one being decomposition, where the organic matter is broken down, but also weathering, where rocks are broken into soil particles, and nutrients are obviously linking directly to that, broken down and reabsorbed into plants. So the soil system then is composed of four main areas. It has minerals, which is about 45% of the soil, and again this is changeable, this is an overall figure only. It has organic matter, which is about 5% of the soil, which is the remains of dead animals and plants or waste produced by animals and plants. It has water, which is about 25% of the soil, and it has air. And all of those are essential to maintaining the ecosystem that soil is. So what are the functions of these different parts of the soil? Well, and what are their sort of characteristics? Well, if we start off with rocks, okay, which obviously make up a lot of the soil, these rocks can be insoluble, which means stuff like gravel, clay, or it can be soluble, such as the mineral salts that are found in the soil. And what they are useful for is because the rocks, the insoluble bits, provide what we call the skeleton of the soil. They hold the soil together, and also they release obviously things into the environment, so the solubles that can be used in the ecosystem. Underneath all the rock, there's the bedrock, which holds like the ecosystem in place. Then you have things like humus, which is the dead organic matter that's in the process of decomposition. That gives it its dark colour, not that that's really a function, but as it breaks down, it does this mineral recycling, returning nutrients back into the soil so plants can absorb it back into the food chain. And it absorbs a huge amount of water. Water itself either moves through the soil or it's been stored in the soil, and this can have lots of different benefits. So it allows the movement of minerals that are dissolved in the soil. It allows it can cause leaching of minerals, taking them from one place to another. It can cause salinization if salt moves up, if water moves upwards, leaving minerals left as a result. And it can cause waterlogging, causing acidification. So it can have lots of impacts, some positive, some not. Air is quite an important thing, obviously. Air is used for aerobic respiration in living organisms in the soil, so they need air to survive, and obviously that's mainly nitrogen and oxygen. And soil organisms themselves are important, so the microbes and the earthworms are part of the decay cycle. And larger burrowing animals also aerate the soil for those. So if we look then, we need to understand that soil is made up of several layers. So as you dig down the soil, you go down from something called the organic layer to the topsoil layer, to the alluviation layer, to the subsoil layer, to parent rock, and to bedrock. And you need to know a small amount about each. Think about it logically, okay, because it's going to be more likely to be organic matter at the top where animals and plants have died, and less as you go down. So the horizon is a distinctive zone invisible in the soil. So the top layer, as I said, is mainly humus. So humus, I should say. Humus is a food, and it has an organic layer. And basically, this is humus, as I said, is a newly deposited organic layer which is starting to be decomposed by bacteria. We then go to the A layer. And the A layer is made of what we call topsoil, okay, and this is a buildup of humus. It's partially decomposed, and it makes it go all really brown in this humus layer, and therefore it's a bit further decomposed than the organic matter layer. Waterlogged soils will form something called peat, and peat is a type of soil where decomposition is incomplete, and that is because when you have waterlogged soil, there is not any oxygen to allow the decomposers to respire, and therefore decomposition is prohibited. We then have the B layer, so we don't need to know about the E layer, we just need to talk about the B layer. And the B layer is the layer where soluble materials from organic matter above becomes deposited. So what we're saying here is the soluble materials sort of come down. So soluble means it can dissolve in water, so they come down in the water into this layer here. And this includes clay and iron salts, so metal salts are often the thing here. We then have the C layer, which is called the parent rock layer, which is partially weathered at this point, okay, and that is, over time it is weathered, which is what is forming the bits of soil as a result. And then we have the last one, the R horizon, which is what we call the bedrock, so that is unweathered parental rock right at the bottom here, which is holding the ecosystem in place. Some soils don't have all A, B and C. They might have two of them depending on the conditions, and in some areas we can't actually dig down to level C because C is too deep down. So we need to understand then, well, what makes soil what makes different types of soil. And there's three main structures to soil which we need to be aware of. And these structures are made up of minerals, obviously, and the soil particles. So these particles depend on what type of soil there is. So if each individual particle in the soil is less than 0.02 millimeters, we call it clay. Okay, so you can see here clay. If the soil is 0.2 to 0.05 millimeters, we call it silt. And if the soil is sandy, which means it's got bigger particles, we call it sand. So you can see how we have a mixture here, and we can work out the type of soil dependent on the properties. So if the soil particles contain mainly clay, we'll call it clay. It can be called clay loam. It can become more silty if it's more over this way. So you could use the soil triangle to identify how much soil is, what type of soil it is. We do not include, it's quite important to point out here, particles are bigger than 2 millimeters, so that is your maximum, because those are not included. So pebbles, for example, aren't included in the soil type. So what are the properties of clay, silt and sand? So the first one is clay. Clay tends to be sticky. You should be able to identify these types of soils if you were given descriptions of them. So clay is a wet, sticky soil that can be rolled into a ball easily. think about the fact that we use clay to make structures in pottery. Silt is like a wet mud, so it's a wet talcum powder. It will hold together better than sand, but it won't be easy to roll into a ball. And sand is very gritty. Think about sand on the beach or building sand. It's gritty and it falls apart easily. Now, perfect conditions for us would be to have all three equally, which is something called, that's what you get, equal quantities of sand, clay, silt soil types. Loam is ideal for agriculture because it has different properties of all of them. The sand allows good drainage and a good air supply, because if you remember sand, we said the soil particles aren't close together, so therefore you've got lots of air spaces. The clay retains nutrients because it's got lots of micro pores between it which hold on to nutrients, and the silt holds the clay and sand together and allows it to work easier when you use it. So we need to know some properties of soil, and we need to understand why these properties are important and link this to loam again, which is a mixture of all three in equal amounts. So first of all, we need to understand porosity. So porosity is the space between particles, so the air spaces between particles. Permeability is how much water and liquids can pass through the soil. And if we look at these two, clay soils have a high porosity because they have lots of tiny little pores called micropores. However, those pores are too small to allow the flow of water through. So weirdly, they have a high porosity but a low permeability. So the water can be stored in there, but it can't pass through. And what this means is nutrients are often highly level there, but the plants can't actually get to them, so they're inaccessible. So clay soil, weirdly, is a rich soil, but it actually has low fertility because the plants struggle to absorb those nutrients. Also, because of these micropores, which are very small and hold small amounts of water, hydrogen ions in the water attach to the clay particles, and that causes a acidic pH, a low pH, which means it means it's acidic. Okay, and that also means the minerals build up as a result. Sandy soils have a high porosity, okay, and that means that this is because they have what we call macropores. So in a sandy soil, you can have lots of big porous holes where the water can collect. But because of these pores, the water, and they're quite big, the water can move from one to another, giving them a high porosity and a high permeability. So you need to be able to explain why both of them have high porosities, because clays have lots of micropores, sand has lots of fewer macropores, but that means bigger. Macro means big, micro means smaller. But the permeability of clay is low because the water movement isn't possible through the micropores, but it's high in sandy soils because the movement of water is easier through macropores.